Good morning, my name is Peter Tomlinson. I'm an extension specialist with Kansas State University. Today we'll be using a rainfall simulator to demonstrate how different conservation practices work. What we've got set up today on the rainfall simulator are 4 different fields that we'll be demonstrating. We have a field that has been conventionally tilled. There's no evidence of the previous crop. We have a field that still has some winter cover crops. We also have a field that's been in no-till production for about 10 years, and it's got residue of last year's corn crop on the surface. The final treatment is soil from a pasture, and so we'll be able to look at how these different fields or different landscapes function in a rain event. We can see that we've got dramatic differences in the amount of runoff and infiltration. Runoff is the water that has run across the soil surface, and that's been collected here in our front jars of the rainfall simulator. So we can see here in terms of the runoff, we have some really sharp differences. Our heavily tilled field that doesn't have any protection, in fact we exceeded the volume of our jars and the water has filled right to the brim. Our next one is our field that still has cover crops that have been growing all winter, and we can see that we've got a lot less runoff. The clarity of the water is better. Our third one is our no-till field. We have had more runoff than compared to the one with cover crops. The water clarity is better than our no-till field. And our final one is our pasture. The water is very clear. We've had very little soil being transported off the surface. Sod that has formed in the pasture, the mat of roots and decaying plant material is really holding that soil in place and protecting it from erosion. So infiltration is the water that moves into the soil when there's a rain event. So our first jar here, which has almost no water, no infiltration water collected, is our heavily tilled soil. Our field with winter cover crop, we've had a reasonable amount of infiltration. Our third one is our no-till field. We have had more than compared to the one with cover crops. The final plot is the pasture, and this one we saw the most amount of infiltration. It's what we would expect. That soil has not been tilled for a long time. So from one extreme to the other, a heavily tilled field that had no infiltration to our pasture that has not seen tillage in a long time, has a permanent grass growing on it, where we saw the greatest amount of infiltration, at the same time the least amount of runoff. We can see, looking at the soil surface here, that force of the raindrops has really beat up the surface of this field. We don't see, in combination with the tillage, we've broken apart the soil aggregates, which are the structural units, the combination of sand, silt, clay, and organic matter. Here where we've had the cover crops growing, we've got some aggregates. Now this field was tilled before the cover crop was planted, so this isn't, I wouldn't say this is no-till, but it does highlight the benefits of having some cover on that field to protect that soil surface. With the rainfall simulator, we're able to demonstrate how the different production practices perform, and we've been able to look at a range of examples today highlighting some of the benefits that using no-till and cover crop production practices have in our agricultural fields.